Hello and welcome to the Geomestic channel. Before we get started, if you have not already, check down in the description. You will find some links to some guided notes for this lesson. If it is helpful for you to write some things down as you follow along, feel free to do so. So in the previous lesson, we investigated two triangle congruence postulates called side, 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 and side, angle, side. If you haven't watched that yet, go ahead and check out that video. Today we're going to add two more of these properties to our tool belt, and they are called ASA, angle, side, angle, and angle, angle, side, both of which you'll notice require two angles and a side to show congruence in two triangles. And the only difference really here is the location of the side that is marked congruent. So let's jump in to the first one, which is going to be angle, side, angle. So both of these should look relatively familiar, as these kind of mimic the same idea as side, 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 and side, angle, side. So angle, side, angle. Which we abbreviate ASA. Angle, side, angle is a triangle congruence postulate that says if two angles in the included side of one triangle are congruent to two angles in the corresponding side of another triangle, then these two triangles would be congruent. So we've got two triangles here, triangle ABC, triangle XYZ. And in these two triangles, you've got two pairs of congruent angles. So say angle A is congruent to angle X, and angle B is congruent to angle Y. So we've got two angles, and then if we have the included side, now what does that mean? The included side is the side that is in between the two angles that are marked congruent. So the side that is included between those two angles, which would be side AB and side XY. Okay, if we have this situation, if this is the setup we have where we have an angle, a side, and an angle in that order, this is enough to prove that these two triangles are in fact congruent. Okay, and again, we did a similar investigation with this with side, 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 and side, angle, side. But if you think about how triangles work, the rigidity of the sides, there's no way that you could make a different triangle if you had this set up. Okay, the only way to connect these vertices here, if these angles are the same as these angles, is to just keep following until you get to point C. You do the same thing over here to Z, and it would follow that these sides as well, including this angle Z and C, they would all match up. They would all be congruent to one another. So this postulate says if two angles in the included side of one triangle are congruent to two angles in the same included side of a second triangle, then those two triangles will be congruent. Okay, we've got the second one, which is angle, angle, side. Angle, angle, side, or AAS. Switch up the letters here, QRS, TV. Okay, angle, angle, side. Just like you would imagine, you've got two angles in the side, but this time the side is not going to be included in between the two angles that you have marked. So angle, angle, side, this is actually a theorem, not a postulate, which we'll talk about here in just a second. The angle, angle, side theorem says that if two angles in a non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the two triangles are congruent. Okay, so two angles in a non-included side. So last time in angle, side, angle, we used this side here on the left. But now we're saying, what if it's a non-included side? So it's not the side that's in between the two angles. Say maybe it's this side. So QS congruent to TV. Now the reason why this is a theorem, not a postulate. If you remember the difference, postulates are accepted as true, theorems have to be proven to be true. The reason why this particular triangle congruence idea is a theorem is because to prove it, we use a theorem that we've seen in the past. It's called the third angle congruency theorem, that says if two angles in one triangle are congruent to two angles in another, because every triangle has to add up to 180 degrees, it will make those third angles congruent to each other. So if you think about this, in this situation, really, I know that angle S is congruent to angle V because of that theorem. So really, if I were to mark that third side, or sorry, the third angle, I kind of already have angle side angle in this case. All right, so we really don't have to take that extra step of saying that those third angles are congruent. Okay, we know based on that third angle theorem that that's true. So really, this is enough. Okay, as long as we have this angle, angle side, angle, angle side. Okay, that's enough to say that these triangles are going to be congruent by that angle side or angle, angle side theorem. Okay, let's do some proofs. For today's proofs, I'm going to try to use a couple different ideas that you might see. Try to make them a little bit trickier than just the average proofs here. So we'll set it up. There's our picture. The given information is going to be that angle A is congruent to angle C. And we're also going to say that segment BD bisects angle ABC. And here we're going to prove that triangle ABD is congruent to triangle CBD. Okay, there's our setup. So triangle ABD congruent to triangle CBD. That's what we know in our two-column proof. As always, statements on one side, reasons why those statements are true on the other side. Okay, the best place to start, as always, is what we know for sure. So if we start with what's given, we know that angle A is congruent to angle C. Always get in the habit of marking the picture if you have information that's given. Put it in the picture. It's easier to see when you can visualize what's going on. So we state that is true. Angle A is congruent to angle C, which has been given to us. Okay, next we've got another piece of information that we know. BD is bisecting angle ABC, which we'll look at in just a second, but we know that it's true because it was given. BD bisects angle ABC. Okay, so that information is given, but what does that tell us? What does the word bisect actually mean? Or what does it mean? So bisect, bi means two, sect means to cut. So really what's happening here is this segment here, BD, is cutting angle ABC into two congruent parts. So if BD bisects angle ABC, so that's up here, that means that segment is cutting that angle in half. What are the two halves? In this case, what are those two angles that are going to be the same because it got cut in half? That's these two up here. So this angle and this angle. Because BD bisects ABC, that will make these two angles congruent to one another. Okay, so we've got it marked in the picture. Let's go ahead and state that those two angles are congruent. We've got this angle here, which is angle ABD, will be congruent to angle CBD. Okay, why were those two angles congruent? They're congruent because of this information here. Because BD bisects ABC, and we know that bisect means to cut in half, the two halves are these two angles here, and those are going to be equal. So the reason why that's true is because of the definition of bisect. Definition of bisect, which is to cut in half. Okay, so already in our statements, we've got two pairs of congruent angles, which is good for our shortcuts today. We've got two angles already, and in this case, all we need is a side. Regardless of where it is, if I have two angles on a side, I know I'm going to be able to prove these triangles congruent. So the question is, do we have a pair of congruent sides? Okay, this one should be, hopefully, relatively obvious by now. Anytime two triangles share a side, in this case, that side BD in the middle, they both line up back to back on that side. We know that is the reflexive property. So we can go ahead and state, number 4, that BD is congruent to itself, BD, due to the reflexive property. And in our picture, we have two angles and a side. The question is the side included in between the two angles, or is it a non-included side? And you can tell, here's the angle, here's an angle, there's the side. The side is not in between the two angles. So in this case, this is going to be angle, angle, side. So once we have enough, what are we trying to prove? We're trying to prove that triangle ABD is congruent to triangle CBD. And we've got this one by angle, angle, side. All right, not bad. Let's try one more. As always, if you need another minute to kind of process that one, feel free to pause the video, rewind, take some time to think about what you've got. But we will move on. Okay, last one. I'm going to try to give you a tricky one today. This one's going to be a little different, hopefully. So in the setup here, we're going to be given a couple of things here. First, I'm going to say that x is the midpoint of WZ. And then we're going to say that WV is perpendicular to WZ. And then YZ is also perpendicular to WZ. And we're going to prove that triangle BWZ is congruent to triangle YZX. This should be X. There we go. VWX congruent to YZX. Okay. All right. Now notice in the given, I didn't tell you any congruent parts. Okay, so this is going to take a few steps here to get everything that we need kind of fleshed out of this. But as usual, the best place to start is what we know. So the first piece of given information is that x is the midpoint of WZ. X is the midpoint of WZ, which is given. Now, the order of these statements, it doesn't really matter which way you go. Some people like to put all the given information first. What I like to do is just start with a piece of given information and then kind of follow that line of reasoning. What does that really give me in this picture? So that's what I'm going to do here first. So if you wanted to put the other given information first, it's fine if you want to put that on step 2, but I'm just going to follow this line. So x is the midpoint of WZ. So what does that tell me? That's really the question. X is the midpoint of WZ. So we know that a midpoint is a point that divides a segment into two congruent segments. So in this case, what are those segments that are the same? WX and ZX. So x being halfway between W and Z will cause those two sides, those two segments, to be congruent to one another. So there's a pair of congruent sides. Let's go ahead and get that in. WX is congruent to ZX. And the reason behind that one, because x is the midpoint of WZ, the definition of a midpoint gives us that information. So we'll say the definition of midpoint. Okay, so there's our pair of sides. That's a good start. Okay, so moving on to the next piece of information that's given to us, I'm going to go ahead and put this all as one step here. So we've got WV is perpendicular to WZ, and YZ is perpendicular to WZ. perpendicular to WZ, which is also given. Okay, so perpendicular. If you don't remember what perpendicular means, it means two segments or two lines that intersect to form 90-degree angles. So it's the opposite of parallel, which never intersect. Perpendicular intersect at exact 90-degree angles. So you can see WV and WZ, it's these two right here. You can see where they intersect at W. I tried to make them as close to 90 as I could. WZ, YZ, also over here. Okay, it's saying that those two lines are perpendicular to each other, and then these two lines are perpendicular to each other. Now again, what does that tell us? What can we get from that? Well, what we can get from that is that angle W, right here where those two first lines intersect, and angle Z where those two segments intersect. Okay, it's telling us that those are going to be right angles. Okay, so number 4, we're going to state that angle W and angle Z are right angles. Okay, angle W and angle Z are right angles. Notice I didn't say that they were congruent to one another, because I didn't say that yet. I don't know that just because they're perpendicular they're congruent. I mean, you kind of do, but you do have to state this first. So angle W and angle Z are right angles. Why did we know that they were right angles? It's because of these lines being perpendicular. So the definition of perpendicular gives us that information. Definition of, I'm just going to use the symbol perpendicular. Definition of perpendicular. Now, because they're right angles, can we say then that they are in fact congruent? The answer is yes, all right angles are congruent. But we had to get this step in first. Okay, we can't just say W and Z are congruent, because the reason we don't really have yet. But because they are right angles, they are also congruent. So now we can say angle W is congruent to angle Z. And the reason being is all right angles are congruent. I do use a lot of symbols when I write my reasons just because I don't have a lot of room. So hopefully that makes sense. All right angles are congruent. Okay, so we've got a pair of congruent angles. We've got a pair of congruent sides. We only need one more thing. Can you see it? Hopefully. Check there in the middle at point X. Anytime you get this bow tie shape where you see two angles opposite of each other at an intersection of two lines, hopefully that should be a tip-off that you're going to see some vertical angles, and that's what we have here. So we've got these vertical angles in the middle, two angles opposite of each other at an intersection. Right there. Vertical angles are in fact congruent to one another. So there's our second pair of angles. So let's get that in our statements. So we've got this angle here, which is WXV. Angle WXV is congruent to angle ZXY. Because they are vertical angles. All right, I think we've done it. We've got what we need. We've got an angle. We've got the side that is included in between those two angles. So if we look at the order that these pieces of information are marked in, we do have an angle, then the side, then the angle with the side in between the two angles. And that's enough. So we can finally say that triangle what did we say? BWX. So triangle BWX is congruent to triangle YZX. And again, the order we have here is angle, side, angle. Okay, kind of a lengthy one this time. And again, because I didn't give you any congruent parts in the given information here, we kind of had to extract that from the picture. But good things to think about: midpoints, perpendicular lines, you might see all those things. Really the question is, what does that tell me as far as congruence? How do I get congruent parts based on those things? And you can see, midpoint gives us two congruent segments, perpendicular lines give us right angles, which are always congruent, and that's how we got to the end here with angle, side, angle. All right, that's it. Thank you for watching. If this is helpful for you, feel free to give it a thumbs up. If these videos are following along on your geometry journey and you just need some extra help, feel free to subscribe. And the best thing you can do is just pass this video along to somebody that you think it would help as well. All right, thanks for watching.